In section 7.4, we have integration by partial fractions, integration of rational functions by partial fractions. This is one of my favorites. Once you get through the algebra, the calculus is really easy. So remember, in lower level algebra, we are given two fractions like this. And we find common denominators, and we work through the math, and we end up with one rational function that looks like this. So what we're doing here is, in calculus, we're taking the answer, the rational function, and we have to split it into two fractions so that we can integrate them separately. The reason is, if you look at this, if you let u equal x squared plus x minus 2, then du is 2x plus 1 dx. So that's not helpful because that's not what's in the numerator. It doesn't have a square root. It doesn't have any trigonometry. Nothing we've used so far is helpful. So what we want to do is we want to do the integration by partial fractions. It's what you learned in pre-calculus. I'm going to remind you of the steps along the way. So I'm going to start off with adding a fraction to help you remember what's going on, and then we'll work down from there. But in general, if you have a function that looks like this, you have a couple cases. If the degree in the denominator is greater than the degree in the numerator. So if you have a larger degree in the bottom, we're going to split it into fractions like this. If you have a larger degree in the numerator, so you have a proper fraction, then what we do is we divide and we deal with the remainder as the partial fraction. Now all of that is just an introduction, so don't stress over it. Let's look at some math. Let's remember first of all that if we have 2 over x plus 3 plus 5 over x minus 4, when we add them, we get common denominators. So we have x plus 3, x minus 4, plus x plus 3, x minus 4. So here I need a x plus 3 as part of my denominator. And on this term, we need a x minus 4 as part of the denominator. So we have 2 times x minus 4 and 5 times x plus 3. So the common denominator is x plus 3 times x minus 4. And on the top we have 2x minus 8 plus 5x plus 15. So that gives us 2x plus 5x is 7x plus 7. And in the bottom we have x squared plus, minus x squared minus x minus 12. So our problem would say integrate 7x plus 7 over x squared minus x minus 12 with respect to x dx. Now use sub doesn't work here. Triangles don't work because there's no square root. So we move into this fraction decomposition. If we can get back to this original problem and write it as two integrals, life is good. So we're going to say, go back to the pre-calc that we learned. Let's put a note here. Note 7x plus 7 over x squared minus x minus 12 equals, now let's go ahead and factor the bottom right here because I could put it on another line, but none of us want to do that. This factors into x plus 3, x minus 4. Now I know this means I have some fraction with the denominator of x plus 3 and some fraction with the denominator of x minus 4. We put a capital A here and a capital B here. This should look familiar from pre-calculus. So what we're going to do now is we're going to multiply every term by the common denominator. They probably would write it, I write it like this so that you can see it happening. But we're going to multiply every term by the common denominator, x plus 3, x minus 4. So on the left-hand side, they're all gone. We have 7x plus 7 equals. On the right-hand side, we cancel out the x plus 3, so we have a times x minus 4, plus b, the x minus 4's cancel, times x plus 3. Don't cross the equal sign. Don't cross the equal sign. So here we have ax minus 4a plus bx plus 3b. So let's rearrange ax plus bx. We're going to put the x's first and then the non-x's, the constants, last. I know they don't look like constants because they have a's and b's, but your main variable here is x. So we're going to put all the x terms first and all the non-x terms last. Now, let's factor out this x, and we have a plus b plus, let's put these two non-x terms in parentheses together. Now, this is important because it compares to what's happening on the other side. Now, what we have here, this is actually a very hard concept. Here I have some x term and I have an x term. They are the same x term. So this a plus b has to equal 7 because the 7 is the coefficient for x and a plus b is the coefficient for x. So when you get those in your head, then a plus b has to equal 7. So let me do that again. A plus b is the coefficient for x. 7 is the coefficient for x. So a plus b equals 7. Secondly, this has no x. This has no x. So negative 4a plus 3b equals 7. So now we're going to do elimination to solve for a and b. I'm going to multiply this by 4. So 4a plus 4b equals 28. I'm going to keep this negative 4a plus 3b equals 7. So when I add them, 7b equals 35, so b equals 5. And a plus b equals 7. So since b is 5, then a is 2. And then you've got to go back to the problem. So let's look at the next slide. So this means that the integration, let's not go to the integration yet. Let's say from here, we can say that 7x plus 7 over x plus 3 times x minus 4 equals a, which is 2 over x plus 3, plus b, which is 5 over x minus 4. Now if we go back, you can see that's what we started with, 2 over x plus 3 plus 5 over x minus 4. So that's kind of cool. So now we can say the integration of 7x plus 7 over, you can say x squared minus x minus 12, or you can put the factored form, they are equivalent, equals the integration of 2 over x plus 3 dx plus the integration of 5 over x minus 4 dx. Now I wrote them as two separate integrals because we need u sub. Let's let u equal x plus 3, then du equals dx. And this is not the same u, so let's let m equal x minus 4. So dm equals dx. So we have the integration of 2 over u du plus the integration of 5 over m dm. Well, 2 over u integrates as 2 natural log absolute value of u plus 5 over m integrates as 5 natural log absolute value of m plus c. So we have 2 natural log absolute value of x plus 3 plus 5 natural log of absolute value of x minus 4 plus c. The absolute value bars are important because when you do the integration of 1 over u, you get natural log of x. So notice the calculus down here is very easy. This calculus down here is very easy. It's just a u sub. The hardest part of the problem is the partial fractions that you're supposed to learn in pre-calculus. So if you looked at that pre-calc and said, this isn't happening in my life, I'm going to let it go, now is the time to go back and pick it up. So we're going to talk about the different cases. So that's your standard normal case. You should probably practice a couple of those in your homework. I know that you have some that look like that with the basic factoring. What I mean by that is it factors into 2 binomials, and it's a pretty nice factoring method. So let's look at one that doesn't go quite like that, but it's not much more difficult, and we'll look at it that way. So this one says the integration of, and the numerator is x squared plus 2x minus 1, and the denominator is 2x to the third plus 3x squared minus 2x, and all of this is over dx. So let's go ahead and factor the denominator. The numerator stays x squared plus 2x minus 1 dx. We're going to factor an x out. So we have 2x and x, 2 and 1, positive 4, so plus 2 minus 1. So now we get to do partial fractions. X squared plus 2x minus 1 over this denominator. Now our denominators here are, first of all, we have an x, and we have a 2x minus 1, and we have an x plus 2. So we put a letter on each, A, B, C. We're going to multiply through by the common denominator. So when we multiply by the common denominator is x times 2x minus 1 times x plus 2. X times 2x minus 1 times x plus 2. I find that students who write it every time are more successful than those who don't. So keep that in mind. I don't know that you have to write it every time. Some students have bad practices here. So we have x squared plus 2x minus 1 equals, the x's cancel. And if we do FOIL, we have 2x squared plus 3x minus 2 plus b. We're going to cancel the 2x minus 1s. bx, x plus 2 plus c, x, 2x minus 1. So this means I'm going to distribute these. We have 2ax squared plus 3ax minus 2a plus bx squared plus 2b x. Don't leave that x off. That could be disastrous. Plus 2cx squared minus cx. So let's factor out an x. Oh, we need to rearrange. So here I have x squareds. When you've done like a ton of these, you might not need this step, where you write them in order. I'm going to skip that step. So I have an x squared, and I'm going to have 2a plus b plus 2c. And here we have an x. So here I have these three terms have an x in them, different from the ones we used before. So x is 3a plus 2b minus c plus, and our term without an x term is 2a. So this equals 1x squared plus 2x minus 1. So this means that our first equation is 2a plus b plus 2c equals 1, because this is my coefficient for x squared and this is my coefficient for x squared. And then we have this as our coefficient for x, as is 2. So we have 3a plus 2b minus c equals 2. And our last equation, we have negative 2a equals negative 1. Well, that's nice. A equals 1/2. So let's plug that into the top. If we plug it into the gray one, 1/2 times 2 becomes 1. So we have 1 plus b plus 2c equals 1. So b plus 2c equals 0. And then if we plug it into the red one, 3 times 1/2 is 3/2, plus 2b minus c equals 2. So 2b minus c equals 2 minus 3/2, which is 1/2. Now here we have two systems of equations. We have a system of equation with two variables. So I like elimination. If we look at them, we have b plus 2c equals 0, and 2b minus c equals 1/2. So I'm going to multiply the bottom equation by 2. So we have b plus 2c equals 0, and 4b minus 2c equals 1. So when I add these equations, we have 5b equals 1, so b equals 1/5. Now I'm going to go back and revisit this equation way back up here. So b plus 2c equals 0. So 1/5 plus 2c equals 0. 2c equals negative 1/5. c equals half of that is negative 1/10. Multiply both sides by a half. So we've got the c equals negative 1/10. C equals negative 1/10. B equals negative 1/5, and A equals 1/2. And we're going to put them into this equation back up here. So we know that the integration, let's do it this way. We have A is 1/2, right? So A is 1/2 times 1 over x, plus B is 1/5. It's the same thing as writing it on the top. It's just easier to work with. 2x minus 1. And C is minus 1/10. And we have 1 over x plus 2. So now we can replace the integral. So the integral says x squared plus 2x minus 1 over x times 2x minus 1 times x plus 2 dx. So we're going to rewrite it as 3 separate integrals. I'm going to write my constants of 1/2 out front. 1 over x dx, plus my b is 1/5, the integration of 1 over 2x minus 1 dx, minus 1/10, the integration of 1 over x plus 2 dx. Now all of these require u sub, but u sub is not difficult. So the first one doesn't. So let's look at the other two. Let's let u equal 2x minus 1. du is 2 dx. So dx is 1/2 du. And let's let m equal x plus 2. So dm is dx, and that's nice. So we have 1/2. The integration of 1 over x is natural log absolute value of x, plus 1/5. We have the integration of 1 over u times 1/2 du, minus 1/10, the integration of 1 over m dm. Now you could take this 1/5 and 1/2 and call them 1/10. I'm just going to do it on the next line. So we have 1/2 natural log absolute value of x, plus 1/10 natural log absolute value of u, minus 1/10 natural log absolute value of m, plus c. So we have 1/2 natural log absolute value of x, plus 1/10 natural log absolute value, and u is 2x minus 1, minus 1/10 natural log absolute value of m, which is x plus 2, plus c. You need to practice this before you do very many, but I'm going to go ahead and do the next part on the next screen. So when you look at the partial fraction problem, there are several cases. Your book says there are 4 cases. I say there are 5. So case 1 is distinct linear factors. Now that's what we did on the last 2, because as you can see, the problem has, it factors into factors that are different and they're linear, mx plus b. So x plus 3, x plus 4, 2x minus 1. Those are the ones we looked at. Case number 2 is where you have repeated linear factors. We have repeated linear factors. let's look at number 19. We can do it with bounds. It'll be okay. So it says the integration of x squared plus x plus 1 over x plus 1 squared times x plus 2. This video may not be long enough, and the bounds are 0 to 1. Now when you look at this problem and you have x squared plus x plus 1, and on the bottom I have x plus 1 squared and x plus 2, we're going to do our partial fraction decomposition. Now when you look at this, you could have x plus 1 once. Well, we know we have it twice. We could have it one time. Think about if you add 1/4 and 1/2, then you could have a repeated factor more than one time. That may be something I need to answer further questions about. But like 1/3 plus 1/9. If you look at this, technically I have 1 over 3 plus 1 over 3 squared. And my common denominator is 1/9, which happens to be 3 squared. So you see how here I have it to the first power, and here I have it to the second power. But we can always, you can always go back and look at that again. So then we need to put our variables on the top. So just like before, we have A, B, and C. So we're going to multiply by common denominators. Now notice our common denominator is x plus 1 squared, x plus 2. Here, all of that cancels, so I'm going to have A times x plus 2, plus one of these cancels here. So I have B times x plus 1 times x plus 2, plus C, and the x plus 1, that's not the right cancel. Let's try that again. The x plus 2's are going to cancel, so I have x plus 1 squared. So this means I have ax plus 2a plus b, and let's do FOIL, x squared plus 3x plus 2 plus c, and let's write it twice and do FOIL, x squared plus 2x plus 1. So we have ax plus 2a plus bx squared plus 3bx plus 2b plus cx squared plus 2cx plus c. So we're going to factor out our x squareds. Here I have an x squared, and here I have an x squared. So I have b plus c. And then we're going to factor out an x. So we have a plus 3b plus 2c. And then our constants are 2a plus 2b plus c. And this equals x squared plus x plus 1. So we're going to build our system of equations. Pause the video and do it on your paper. So we know that b plus c equals 1. And a plus 3b plus 2c equals 1. And 2a plus 2b plus c equals 1. I'm going to eliminate the a's here. So I'm going to say negative 2a minus 6b minus 4c equals negative 2. 2a plus 2b plus c equals 1. So these cancel. Negative 4b minus 3c equals negative 1. Now I'm going to put that with the other one. So I have negative 4b minus 3c equals negative 1. I'm going to multiply the top equation by 4. So I have 4b plus 4c equals 4. So the b's cancel, and c equals 3. Now since b plus c equals 1, b plus 3 equals 1, not c, 1. So b equals negative 2. And then a plus 3b plus 2c equals 1. A, 3 times negative 2 is minus 6. Plus 6 equals 1. So a equals 1. So now we have the integration from 0 to 1, x squared plus x plus 1 over x plus 1 squared over x plus 2 equals the integration from 0 to 1, and we have a over x plus 1 squared, and a is 1 dx, plus, I'm going to write them as separate integrals, 0 to 1, b, which is negative 2, over x plus 1 dx, plus c, which is 3, over x plus 2 dx. So this is several u subs. Let's let u equal x plus 1. So du is dx. The same u equals x plus 1. So du equals dx. And then m equals x plus 2. And dm equals dx. So we have the integration from 0 to 1. 1 over u squared du plus negative 2 over u du from 0 to 1, and the integration from 0 to 1 of 3 over m dm. So the integration of u to the minus 2 is negative u to the minus 1 from 0 to 1 plus, let's change that to a minus 2, and the integration of 1 over u is natural log of absolute value of u from 0 to 1, plus 3 natural log absolute value of m from 0 to 1. So we have negative 1 over u is x plus 1, minus 2 natural log absolute value of x plus 1, plus 3 natural log absolute value of x plus 2, all from 0 to 1. So when we put in 1, we have negative 1 over 2, 1 plus 1, minus 2 natural log of 2, plus 3 natural log of 2. Oh, that's not natural log of 2. 1 plus 2 is 3. We don't need absolute value symbols because it's all positive. Minus parentheses, negative 1 over 1 is negative 1, minus 2 natural log of 1, plus 3 natural log of 2. Natural log of 1 is 0. So here we have minus 1/2, minus 2 natural log of 2, plus 3 natural log of 3, plus 1, minus 3 natural log of 2. 1 minus 1/2 is 1/2. I have minus 2 natural log of 2 minus 3 natural log of 2. That's minus 5 natural log of 2 plus 3 natural log of 3. Now we could combine those. So we have 1/2. Natural log of 3 to the third is on top. That's 27. And 2 to the fifth is underneath. That's 32. Oh, 1/2 plus. So that would be our final answer. So that's case 2. So when you have a repeated root, when you do your partial fraction decomposition, you're going to put it to the maximum power and continue till you have all the minimum powers included. So if this was x plus 1 to the third, you would have an x plus 1 to the third, an x plus 1 squared, and then another one which would be an x plus 1 in the denominator. Thank you.